Hello my good friends, and welcome to the week 7 Create video presentation. Okay you guys, I just had to throw a little Beatles in there for you, and here comes the Create presentation. This is what happens. Chapter 7 is about estimation. What that means is we're going to create a 95% confidence interval around a mean, so that we know that 95% of the time the mean will fall within 2 scores. And the reason we're using 95% is because that is the standard coin of the realm for all of us little statistics, social science students. You remember the normal curve. I pointed out one of the properties to you is the percentages between each standard deviation is fixed, and therefore 34.13% of the cases falls in here. If you add that to the other one right above the mean there, you're going to end up with 68%, and then 95%. Well, in point of fact, we can make this a little more accurate. I'm going to explain my symbols to you here real quick. This is the population mean, this little Greek U letter, it's called mu. This thing is the symbol for the standard deviation. This is the sample mean, that's the sample standard deviation, and standard error of the mean is what we're going to use to create our confidence intervals. The sample mean has 2 characteristics, as you'll remember. One is bias and the other is efficiency. Bias just simply means if it's biased, it's not accurate for the population as far as we're concerned. So we want unbiased, meaning not skewed, not unrepresentative, not freakish in comparison to the population mean. Efficiency means that we are clustering of the scores around the mean in a very tight configuration. Hopefully they aren't all spread out. This gives us the ability to make accurate predictions and accurate estimates. My example makes use of the Scholastic Aptitude Test, which you know as the SAT test. The population mean of that test is 1,000, and the standard deviation is 200. Usually we don't know the population mean and the population standard deviation, but for the SAT test we do, because we have access to every score in America. Now, where do we get the normal curve from? We randomly draw, we pretend as if we're randomly drawing thousands and thousands of means, and we're constructing a data set out of nothing but means. That gives the normal curve that perfect symmetrical shape. It's not skewed, and it's not disshaped in some kind of way. So the first mean that we pretend we draw 1018, 943, 961, 1059. We get all these different means, and then we plot them on the graph, and once we get them all, it shapes the normal curve exactly like we want to shape it. We know from the Z-score chapter that we use 1.96 to construct the 95% confidence interval, meaning 95% of the scores are contained between these 2 lines, and only 5% are outside those lines. And like I said before, we pretended like we were drawing each mean at random until we had them all sampled, and that's called the sampling distribution. Now, we have a sample mean on our SAT scores of incoming college students of 1023. The population mean, as you noticed, is 1,000, and with the standard deviation of 200. On our sample size, we're saying is 100. This is what we do. First thing we do is compute the standard error of the mean, which gives us that standard deviation that we can make use of to construct our 95% confidence interval. Turns out that the standard error mean is square root of the sample size, which is 100. That would mean the samples, excuse me, what I mean to say is standard deviation divided by the square root of the sample size. So our sample size is 100, square root is 10, and here comes 1.96 standard deviations on either side of the mean. And 1.96 standard deviation above the mean is going to fall 39.2 points above it. In other words, 1,039 points. Below the mean is going to fall at 960.80. So that means what we're saying here is we have computed a 95% confidence interval that we're confident that our mean is accurate as long as it's between 960.8 and 1039.2. Since our mean was 1023, we're cheering with joy. We're saying our mean is accurate. Yay. So that's my sample presentation for you, and you can do whatever you want, use scores and data sets from wherever you want to get them. And that's our chapter 7, so I'll see you next time.